Hello, in this episode, I thought I'd talk about times tables, partly because it's something when parents get in touch, I often talk about as it's easy to explain our methods of doing things, which I'll go into in a second. But also times tables, it's a bit like adding and subtraction, division. It's kind of the foundations of maths. And without those, it's really hard to kind of like take your level of understanding any higher. So if I go back to the beginning and start by explaining a little bit about how we learn. I apologize if you've heard this before and feel free to skip ahead. But one of the things I learned many years ago when I was learning about different learning styles and in particular dyslexia is that if we if as a parent, as an educator, you just keep giving the child one thing to do over and over again, which is very often worksheets. We can download them off the internet, we can buy the books where you just work through them from beginning to end. What we're doing is we're giving that child one memory, one place to go to where it can find that piece of information. So then when they're sat in a class and the teacher suddenly goes, what's the answer to that? Or they're in a test and the question is this, what's 9 times 4? Or whatever the scenario is, for some reason they need that answer. Their brain only has one place to go to where it can find that piece of information. But if we use multiple different resources, that way we're helping them to create multiple different memories. So like I say, when a parent gets in touch, I often use times tables as an example because it's an easy one to use. So I might suggest that we might play a pairs game, or so you've got all the cards laid out on the table in front of you. Some have the questions on, some have the answers on, and you have to pick up a corresponding question and answer. So for example, I might pick up 6 times 9 and I pick up 18. So that's wrong. So I put them back down where I found them and the other person has a go. They pick up 6 times 9 and they pick up 54. They've got the pair. So they keep the pair and have another go. We might play bingo, we might play snakes and ladders, we might play noughts and crosses. A lot of people know it as tic-tac-toe. So you draw the two vertical lines and cross them with two horizontal lines, creating a kind of like 3 by 3 grid. And then in each of those parts of the grid, you put a number. So up to, generally speaking, up to 12. And then you pick the times table that you're practicing. So say it's fives, and in the bottom left-hand corner, there's been a number 11 written. So before I can claim that square, I have to work out what 11 times 5 is. I tell the other person the answer, and then I can claim that, put my nought or cross or scribble or whatever you're using there. And it's just a really quick and easy game to prepare and play. And then within 5 minutes, you've done some times tables practice for the day. And so that's one I often recommend to parents. And it's one that we often use at Clara James just to kind of like squeeze into 2 minutes before the lesson ends or something like that. But what's very common when we're supporting children with learning the times tables is that we'll do the twos, the fives, the tens, because they're easiest and that's the way they do it at school, and the 11s as well, probably. Okay, so I've got the twos, the fives, tens, 11s in the bag sorted. And then we go back to going 3, 4, 5. Oops, sorry, 3, 4, got the fives, 6, 7s, 8s, 9s, 12s. So kind of like doing the rest of them in chronological order, which is it's fine, but there's easier ways to do it. So the purpose of this, what I thought was I would explain the hows and whys of possibly working in a different order to a chronological order. So the one times table is obviously easy. That's just kind of like 1 times 2. I've got one lot of 2, so my answer is 2. I've got one lot of 3, so my answer is 3, and it just carries on as so. Doubling is, I presume, taught fairly early on because it's easy to use kind of like physical objects to kind of like show you that I've got 2 buttons here and another 2 buttons here. So 2 add 2 is 4, 3 add 3 is 6. And because the child by this stage has probably already done kind of like basic adding, this is fairly easy that if I say to you 4 add 4 is, and you'll go 8. And so I just have to adapt it slightly to kind of go, look, when I do 4 add 4, I've got 2 here. Oh, sorry, I've got 4 here and I've got another 4 here. So I've got 2 lots of 4. What's the answer? And you'll go, oh, 8. So twos are quite straightforward. Then we come to the fives. No, let's come to the tens first because that's even easier, because literally all I'm doing is moving the decimal point along one place and filling that gap with a 0. So I'm making it 10 times bigger. hence it's timesing by 10. So the 10 times table is literally, okay, 1 times 10 is 10, 1 with a 0, 2 times 10 is 20, 2 with a 0, 3 times 10 is 30, 3 with a 0, etc. And no matter how big the number gets, we could do kind of like 99 times 10 is 99 with a 0, 990. So the 10 times table is easy. So that should logically come next. So we've done the 2s, we've done the 10s. Then we'd probably move on to the 5s because again, that's got a nice easy pattern. The answers go 5, 0, 5, 0, 5, 0. And then if we look a bit deeper, the odds end in a 5. 1 times 5 is 5, 3 times 5 is 15, 5 times 5, 25. So all the odd numbers end in a 5, all the even numbers end in a 0. Okay, so that's quite straightforward. So next we'd move on to the 11s. And once again, the 11s quite straightforward because we've got 1 times 11 is 11. 2 times 11 is 22. So I've got the 2 and I just put 2, 2. I've got the 3 times 11, 3, 3, 3. And the reason that works is because I'm basically doing a 1 times 2 or 1 times 3 and then another 1 times 3, 1 times, and just putting them in the proper position with their place values. And so the 11s are once again up to 9s, fairly straightforward. 10s we've already conquered because we know now that that's just a case of putting a 0 on the end. And a trick that a lad I was working with the other day taught me was if I'm doing 12 times 11, no, sorry, 11 times 11, I split the 11s and I put a 2 in the middle. If I'm doing 12 times 11, I split the 11, I split the 12 and put a 3 in the middle. If I'm doing, actually, I'm going to stop there because doing it without writing this down, the brain is just going to confuse itself. So it doesn't work on such a high level. So now I've done the 1s, 2s, 5s, 10s, 11s. So that's the first 5 I've pretty much conquered. But the thing is, it's the same with any times table, or with any element of learning, don't try and rush. Just slow and steady wins the race in this example. I mean, I was working with a child yesterday and they were kind of going, we were talking about something completely different. I think we were playing snakes and ladders, and I was losing, and I kind of like went, no, slow and steady wins the race. It's not an issue. I'm still going to beat you. And they went, well, no, because while you're going slow and steady, I'll have already reached the finish line before you're still kind of like caught up with me. Yeah, that's true. But in the case of learning times tables and most things, just do it slowly and make sure you're 100% confident with that bit before you move on to the next bit. Because if you try to rush, you're never going to have those foundations completely secure. And if they're not secure, it makes it so much harder to be able to move on to the next bit. So slow and steady. So the next one I recommend we do is the 9 times table because there are so many tricks with the 9 times tables. For example, when I write them down, I start with 0, 9, 1, 8, 2, 7, 3, 6, 4, 5, 5, 4, etc. So my 10s column is going up by 1. My 1s column is going down by 1 each time. So I can, if I'm at the early stages of learning it, I can just write it down, potentially, hopefully, as a kind of bright, colourful poster, which by using at least 5 colours, again, it stimulates the brain in more areas, making it easier to remember. So whether this is for kind of like any learner, not just kind of like dyslexic, so I get my words out, not just dyslexic learners, which I know I started off talking about initially, but so it's nice and easy to see the pattern. The next thing you can also do is check, because if I say 5 times 9 is 45, so 4 add 5 is 9. Okay, I must be right. 8 times 9 is 72. 7 add 2 is 9. Let's try a slightly harder one. 12 times 9. Okay, 108. 108. 1 plus 0 plus 8 equals 9. And so no matter what the answer is, the digits will always add together to make 9. And it's just an easy way. If I tell you my answer is 73, 7 plus 3 is 10. Okay, I must have got that wrong. What is my answer? Okay, 72. Okay, I know I'm right now because 7 plus 2, 9. So it's just another really easy method of double checking your answer. And then the next example is going to be really hard to show you without actually physically showing you. But so if you're listening to this as a podcast, I apologize and I hope what I'm about to say makes sense. If you're watching it on YouTube, brilliant. Hopefully you can see my fingers. So if you were to be asked 3 times 9, what you would do is put your hands out in front of you, put your third finger on the left hand side down, and everything to the left of your third finger are your tens. Everything to the right is your ones. So counting from the left, I have 10, 20, switch. That's when my third finger is down. And I'll switch to the ones now. So I've got 20 already, 21, 22, 23, 24, 25, 26, 27. 3 times 9 is 27. Okay, let's try another one. Let's try 6 times 9. So I put my sixth finger from the left, sorry, down. So once again, everything to the left is a 10, everything to the right is a 1. So I've got 10, 20, 30, 40, 50, switch, 51, 52, 53, 54. Okay, and I always say switch when I get to the number that's down because that's kind of like that reminder that you stop counting in tens and you start counting in ones, and that finger isn't actually included. And so for up to 10 times 9, that's a really helpful method to use. And it either confuses people 100% and they don't want to go there, or they love it and they grasp it really quickly. So hopefully it'll be one of those ones that you can just grasp and it makes life so much easier. Another method you can use is times by 10 and then take one group, erase the same. I'm doing 3 times 9. I could do 3 times 10 is 30, take off one group of 3, which would leave me with 27. So as you can see with the 9 times table, there's just kind of like an abundance of methods of helping you to learn it, which is why it's one of the ones I'd kind of like go, well, don't do it in chronological order. Do that first because it's so much easier. And then once you've got those ones, the rest of them can be much more haphazard, I guess, in the order in which you learn them. So for example, and that's because most of them can be cut down into smaller numbers. So for example, if I was to give you 7 times, you need to learn the 7 times table. That's one of the harder ones. Yes, it is. But by now you know your 5 times table and your 2 times table. So if you were to break, supposing you were given, let me write this down for myself. So supposing you were given 7 times 8 as a question. Okay. You know that 5 times 8 is 40, and you know that 2 times 8 equals 16. So if I add those two numbers together, I now have the answer to 7 times 8 because I've got 5 groups of 8 here and 2 groups of 8 here. So altogether, I've got 7 groups of 8. So my answer is 56. And that suddenly makes the 7 times table so much easier to learn because I know my fives, I know my twos, and I can add. And so, hey presto, that's the 7 times table. The 6 times table, again, you can split it. So it's 5 groups and one group. So 5 times whatever, 1 times whatever. The 3 times table you can do is 2 times and 1 time. Fours, you could either do, what I would probably do is just double the answer to the 2 times table. So if I was asked, say, 4 times 8, I would go 4 times 2, I know is 16. And so I'll just double that. So 16 add 16 is 32. Hey presto, that's the answer. And so for the rest of them, that's how I would potentially approach them, is by splitting it down into smaller numbers. So I hope that's really helpful. We have a series of emails, which if you'd like to sign up for them, I'll put the link in the comments below. But each month we'll send you a series of resources associated. So for the first month, I think it's the 2 times table. There's a series of resources that you can use to help you support learn the 2 times table. I think the next month is potentially the tens. And so again, there's a series of resources to help you learn the 10 times table. If you're a member of the Clara James Approach, our membership group, which at the minute is about £3.50 a month, you'll find some resources again and the times tables in there. And we're also putting together basically a colouring by numbers, but the numbers are determined by the answers of the times tables. So if you're not interested in the times tables, or sorry, the Clara James Approach or the other thing, but you want to kind of be kept up to date, keep listening to the podcast, or let me know and I can send you out. Each week we do an email on a Monday, which is based around ideas supporting primary school children, and then on Thursdays we have an email which is based around ideas for supporting secondary school children. So if you think either of those would be of value for you, let me know, and I can add you to the list and ensure that you get them. And um, if we do have anything new, like the colouring books or anything, or the topic books, or new courses, or anything else, we often have competitions and giveaways within those emails. So if any of it at all would be useful for you, let me know, and I'll make sure that you receive the emails. Thanks for listening, and I will, on that note, say goodbye from me. I'm Dawn from Clara James Tutoring. Clara is my oldest daughter, Jamie is my son. The logo is an angel, which is named after my youngest daughter. I hope you enjoy the rest of your day. Take care, and I hope this has been helpful.